Welcome to Fast Math Solutions on Maths with EJD. In this video, I'll be talking about the Leibniz Theorem, which is something related to the product rule for differentiation, and that's talking about calculus, right? So let's see what Leibniz has to say about this. By the way, Leibniz is one of Leibniz and Isaac Newton, I believe, were the two people that were said to have worked on, you know, coming up with what we know as calculus today. So let's look at what Leibniz has to say. Leibniz theorem states how to differentiate the product of two functions. I definitely talked about product rule under calculus, and even in this fast math solution playlist, I think I talked about the derivation of for the formula for product rule. So Leibniz is bringing another twist to that. So Leibniz theorem states how to differentiate the product of two functions. Okay, and this is how that goes. If u of x and v of x are differentiable functions, the derivative of their product is given by, because this is a very well-established formula. So their derivative is given by d dx of u of x multiplied by v of x, and that is equal to u prime of x. That's differentiate u and multiply it by v of x, then multiply u of x by the derivative of v of x. That's a well-known formula, you know. So that's the basic idea, but then it doesn't end there. So what if we're interested in higher derivatives? So let's consider for so we now have a formula for higher derivatives. So I mean, we have just one derivative. What we have up there is just for the first derivative. What if you are interested in second, third, fourth, and all of that? So imagine that the nth derivative, the nth derivative of the product of two functions is, now you know this is for first derivative. So what if we need like the nth derivative for the product of two functions? So this is what that looks like. So we have nth derivative, the xn, that's the nth derivative, right? Of u of x, v of x. The nth derivative is such that we have summation from k equals 0 to infinity. And this is beginning to look like binomial theorem, right? So you have n combination k, interestingly. Then you have u k, okay? So that k there talks about the kth derivative, uk of x, then v n raised power n v raised power v, the n minus kth derivative of v of x. I mean that sounds somehow, but I'll do an example to drive home the point actually. So you have u raised power k of x. That's the kth derivative of u of x multiplied by the n minus kth derivative of v of x, and that's how that works. But of course, to know the component parts, right? Like we always like to do. So you need to know that, of course, this is not new. N combination k is the same thing as n factorial over k factorial n minus k factorial. And that is the binomial coefficient. This is the binomial coefficient. Okay. Then you have u uk of x is the kth derivative, like I said before, is the kth derivative of u of x. And then we have v, right? V n minus k. That's the n minus kth derivative of v of x. So this is the n minus kth derivative of v of x. And that goes. So let's take an example and see how that goes. So, example, find the third derivative, find the third derivative of y equals x squared e raised to power x. Okay, so the solution to that solution. So first thing, we can say let u be equal to x squared, right? U is equal to x squared. So, and since we are talking about third derivative, so just do three derivatives like that. So this is u prime prime of x. When we differentiate x squared, I mean, this is u of x is x squared. So first derivative, sorry, first derivative, when you differentiate x squared, you get 2x. Then second derivative, when you differentiate that, you get 2. And then you talk about the third derivative. And when you do that, you get 0. When you differentiate 2 being a constant, you get 0. Okay. Then automatically v of x now, if v of x, so this is u of x. V of x now is e raised to power x. So e raised to power x. So now you have v prime of x. That is simply e raised to power x. V prime prime of x. That doesn't ever change, e raised to power x again. So even the third derivative gives you the same, v prime 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 of x. And that is equal to e raised to power x still. So it remains the same all the way. Now, we can now apply the formula. Let's apply the formula. Don't forget, this is as good as, so this v of x is this. So this is as good as v1 of x. So k here is 1. Or maybe I should just indicate that. So for this, k here is equal to 1. K here is equal to 2, that second derivative. And k here is equal to 3, third derivative. And when you come up here, so k here is equal to 1, k here is equal to 2, and k here is equal to 3. Okay, 3, not just 2 strokes, like 3 like this. Okay, so let's apply the Leibniz formula for n equals 3. So applying the Leibniz formula for n equals 3. So that means the 3, the x3, that's the third derivative of u of x, v of x. That would just be summation from k equals 0 to 3 because n is 3, right? From k equals 0 to 3. Then n combination k, that's 3 combination k, 3 combination k. Then u, the kth derivative of u of x, the kth derivative of u of x multiplied by the 3 minus kth derivative of v of x, basically. So let's break that down. Let's expand that and see what that gives. So that means we have this to be equal to, so first of all, you have 3 combination 0, and then because the derivative is 0 here, so that's like u0 of x, v 3 of x. That's the third derivative of x for sure. And then the next one would be 3 combination 1, first derivative of x, then so 3 minus 1, that's the second derivative So that's like when you have two strokes, right? You can put this in bracket too. Second derivative of V, okay? So then we go on and we have 3 combination 2. Then the second derivative, I can write that as a number. Second derivative of x multiplied by the first derivative of V. Okay. Hope it's not too small. I want to make sure everything is occupied in one line. So 3 combination 3 now. So you have u, the third derivative of V of the third derivative of u of x multiplied by the 0th derivative of V of x. That's the idea. So what does this tell us? Okay, let me just change this now. So we have the third derivative, the x cube of u of x, V of x now is equal to 3 combination 0. 3 combination 0 is 1. We've done that a lot of times. um the 0th derivative of u of x, that's like u of x. The u of x is as good as the 0 derivative of u of x, and it's like the 0 derivative. That's when you have not differentiated it at all. So u0 of x is actually x squared. Then the third derivative of v, this is it here. So that's e raised power x. That's for the first one. Then 3 combination 1, we know that is 3. Then first derivative of u, that is 2x. Then second derivative of x, of v rather, that's e raised power x. Then 3 combination 2 is also 3. Then second derivative of u is 2. Then first derivative of v is e raised power x. That doesn't ever change. Then 3 combination 1 is 1, this now. Then the third derivative of x, interestingly, is 0. And the 0 derivative of v, that's e raised power x. Nothing changed for that. So then we tidy up all of this. So this is 3 combination 0. This is 3 combination 1. This is 3 combination 2. 3 combination 2, this now. Okay. So we can tidy all of that up. And then we have, so here, this is x squared, e raised power x. Then next one is 6x e raised power x. This second one is 6x e raised power x. And here we have 6 e raised power x. And then the whole of this is 0. Okay. So this is this now. Then the whole of this is this. The whole of this is this. Then the whole of this is 0. Okay. So from what we see there, we can say that the third derivative, the cube, the x cube, the x cube of u of x, v of x now, is equal to x squared e raised power x plus 6x e raised power x plus 6 e raised power x plus 6 e raised power x. And we can factorize e raised power x. So we have e raised power x into x squared plus 6x plus 6. And that is the result. So that's the idea of Leibniz theorem. So if you are going fifth derivative, you just apply the formula just like that and go your way. All right. So that's how that works. So get all the derivatives and plug into the formula and follow step by step. Okay, with this, I come to the end of this video. If you have not subscribed to this channel, there's a lot you have to learn. So do that right away. Hit the notification bell so you can always get alerted each time a new video is released. And then comment, let me know how helpful this video is. Let me know if there's a problem you'd like me to solve or a topic you'd like to teach. For instance, this is actually a request from someone who follows me on Facebook, right? So I had to do that because of the person. Then of course, like and share so that more people can have access to this great learning. Till I come your way again, keep doing maths right. Bye.